Hello everyone, welcome back to Diksha Vedantu YouTube channel, and today I am going to discuss the physics portion of your sample paper 2. The sample paper 2 is shared in our WhatsApp channel. You can download the question paper from there and you can check what are all the portion of physics questions. So without any delay, let's start with today's question paper analysis. So first we have two MCQs and one assertion and reason question. So one marker question, we have only 3 marks from this sample paper. We have two marker questions, so that is 4 marks from there, and we have 3 marker question, so total of 9 marks. And most important, we have 1 5 marker question and 1 4 marker case study based question. So these are the question paper analysis, and 25 marks you can score from physics portion if you have studied this correctly, right? So let's start with the 1 marker question. An object is placed in front of a convex mirror. So here they have said a convex mirror, an object is placed on the convex mirror. Okay, its image is formed. Convex mirror, obviously we know that it always forms virtual image, and it is always formed diminished image at a distance equal to the object distance in front of the mirror. Obviously not, it will always form it will be always diminished, it will be always behind the mirror, because it is a mirror, so virtual images will be behind the mirror. So you can say the image will be always less than that of the object distance, no matter what, at twice the distance of the object from the mirror, half the distance of the object front of the mirror, behind the mirror, and its position varies according to the object distance. Yes, behind the mirror and its position varies according to the object distance. So basically there is no direct relationship. We know that 1 by v is equal to 1 by u is equal to 1 by f. Based on that equation, object distance varies, image distance varies, so there is no direct relation. Like in case of plane mirror, image distance and object distance are always equal, right? So there is a direct relationship. In case of mirrors, spherical mirrors, the relationship is slightly complicated. It is based on the mirror equation, right? So the correct option is option D. Now let's look into the next question, question number 14. When light enters the atmosphere, it strikes on the extremely fine particles which deflect the rays of light in all possible directions. This is due to reflection of light, atmospheric diffraction, scattering of light, dispersion of light. The scattering of light, this is scattering of light because light is getting scattered in all possible deflection, all possible direction due to the particles present in air. That is called scattering of light. Refraction happens when light changes one medium to another medium. When light travels from one medium to another medium, the light bends. That is called refraction. Be it normal refraction, be it atmospheric refraction. Refraction happens due to change in the density of the medium, right? So that is not atmospheric diffraction. So these two options may be appear to be very close, but it is not. Also, dispersion of light happens when light travels through a prism or prismatic shape, right? When light travels from prismatic shape, it bends, it disperses into different colors. That is why it is called dispersion of light, not scattering. Here the example given is called scattering of light. Now question number 19, it is an assertion and reason based question. What is the assertion said? A compass needle is placed near a current carrying wire. The deflection of the compass needle decreases when the magnitude of the current in the wire is increased. So very important thing, that when the compass needle is placed in near a current carrying wire, it will deflect. And if the current in the wire increase, the deflection will increase, because the relationship between deflection and current is directly proportional. So if current increases, deflection will definitely increase. But here they have said needle decreases, so definitely this is a wrong statement, so assertion is incorrect. Let's see what about reason. The strength of a magnetic field at a point near the conductor increases on increasing the current. Yes, this reason is correct. The strength of the magnetic field near the conductor increases with increase in current, so definitely that is why when so if it was increases, if the statement was increases, then this would have been the correct explanation. okay, but because it is wrong, so only reason is correct, okay. A is false, R is true, okay. So A is false, R is true, option is option D. But be careful in the exam, if the same question was asked and instead of decreases, if they give you increases, then both will be correct. Not only that, reason will be the correct explanation for assertion, right? But because of this decreases term, only one term makes the assertion incorrect and makes the reason correct, right? So be careful in the exam, in case they ask you the same question, instead of decreases, if they change this line to increases, then not only assertion will be correct and reason is already correct, but reason is the correct explanation for the assertion. So you have to understand these kind of small changes, right? Now let's move on to the next questions, next part, that will be 2-marker question. Let's see. The refractive indices of 3 media are given below. So there are 3 mediums are refractive index. Refractive index of A is 1.6, refractive index of B is 1.8, refractive index of C is 1.5. A ray of light traveling from A to B and another ray is traveling from B to C. So what are the 2 mediums? So first case, ray is traveling from A to B. Okay, so let's understand that A has a refractive index 1.6 and B has a refractive index 1.8. So what will happen? So a light ray is traveling from rarer to denser medium, so definitely it will bend towards the normal. Okay, whenever light ray is traveling from rarer to denser, it bends towards the normal. So this is the normal case. Now what is the second case? Second case is light ray is traveling from B to C. So B to C means again the ray is falling. Now here the refractive index of B is 1.8 and refractive index of C is 1.5. So in this case, light ray is traveling from denser to rarer medium, so it will bend away from the normal. Not only that, there is a possibility of total internal reflection. Now let's see what are the question. Which of the 2 cases the refracted ray bend towards the normal? So obviously, as we have seen, the ray bends towards the normal when light ray is traveling from A to B. So first case we observe light ray bending towards the normal. In which of this case does the speed of light increase in the second medium? Give the reasons for your answer. So when the light ray is traveling from one medium to another, okay, based on the fact that higher the refractive index, okay, less is the speed of light, right? So higher the refractive index, less is the speed of light in that medium. So because we know that refractive index for air, okay, refractive index for air is 1, where speed of light is maximum. Okay, refractive index of water is 1.33 approximately. Refractive index of glass is 1.5. So as the light travels from rarer medium to denser medium, okay, the speed of light decreases. When the light travels from denser to rarer medium, speed of light increases. So in the second case, B to C, the speed of light increases. Now let's see exact what explanation they have given. When the light travels from optically rarer medium to optically denser medium, so this is very important term to mention when you are answering, that this is an optically denser, or higher refractive index is also okay if you mention higher refractive index to lower refractive index, or lower. So refractive index in terms of refractive index is fine, or you have to mention optically rarer medium to optically denser medium. Optically denser medium means higher refractive index, this is lower refractive index, and here it is higher refractive index. Okay, that is also fine. Medium moves towards the normal. Since NB greater than NA, here the light ray will bend towards the normal on passing from medium A to B. Okay, so both part, first of all you have to mention that when it happens. So as I said, lower to higher light ray is traveling from lower refractive index to higher refractive index. That is the first part, and second part you have to identify which one it is, right? So first you have to give the explanation and then you have to answer correctly, then you will get 0.5 plus 0.5, that is 1 mark. Okay, now let's see that part B. The speed of light will increase when light travels from B to C, since in C is less than NB. As I said, as the refractive index increases, speed of light decreases, right? So in this case, as they have mentioned that NC, the refractive index of C is less than that of B, right? So NC is less than NB and V is equal to C by N. So there is a relationship between speed of light, that refractive index is basically C by V, right? C by V. Now higher the refractive index, lower is this V. Why? Because you can find V to be as C by N. C is the speed of light in vacuum, which is a constant, 3 into 10 to the power of 8 meter per second. So higher the refractive index, lower is the speed. Okay, so based on that explanation, you have to say that when the light travels from B to C, the speed of light increases. The question was speed of light increases. So because it is traveling from optically denser medium to optically rarer medium, speed of light will definitely increase. Okay, second medium. So if you write this explanation, this equation is not compulsory, but this is compulsory. This part is compulsory. Refractive index of C is less than that of CB. Okay, higher the refractive index, lower is the speed. That line you have to mention. Higher the refractive index, lower is the speed. So when the light ray is traveling from higher refractive index medium to lower refractive index medium, definitely the speed of light will increase. So based on that, you will get 0.5 marks. Okay, 0.5 marks is given for the correct identification, 0.5 marks is given for the correct explanation. Okay, now there is a chance the student think that 0.5 marks will not be awarded, but it is a myth. 0.5 marks can be awarded. Okay, as you have seen, 0.5 marks can be awarded to the students because it is mentioned in the sample question paper. So if you see model question paper or the marking scheme of the paper, definitely 0.5 marks can be awarded based on the answer. So if you just answer it, you will not get full marks. Without explanation, basically you are leaving half of the marks in the question paper table, in your answering table, right? Remember that answer has to accompany with the explanation. Now next part, question number 25. A piece of wire of resistance R is cut into 3 equal parts. Okay, these parts are then connected in parallel. If the equivalent resistance of this parallel combination is R1, what is the value of the ratio R1 is to R? So we will solve that in a while, but let's look into the second part also. Refer the image below and state how the magnetic field pattern indicates the region where the magnetic field is stronger outside the magnet. What happens to the magnetic field when the current in the circuit is reversed? So first of all, there is a solenoid and they have said, okay, where the magnetic field strength is maximum outside the magnet. Okay, so very easy question. This question is easier. So as you can see that magnetic field lines are mostly stronger here in the region just along the length of the solenoid. So magnetic field will definitely be stronger here, and if you reverse the current in this solenoid, okay, the magnetic field lines will be reversed because the direction of current changes, direction of current exactly reversed. So if the direction of current exactly reversed, okay, then definitely the magnetic field lines direction will be reversed. So suppose in this case, suppose this is south pole as it's shown in the diagram, this is north pole. Okay, if you reverse it, once you reverse, then it will become north pole and this is south pole. Okay, when this is reversed. Okay, So once the battery is reversed, the north and south pole will be reversed. Now let's see the first question. This is a mathematical question, easy question, not super difficult. So a piece of wire of resistance R. So resistance of the piece of wire is R, okay, and it is cut into 3 equal parts. So 3 equal parts means, suppose I have a resistance wire, okay, you cut it into 3 equal parts. Total resistance was R, okay, and then connected in parallel. So first the resistance of this wire is R. Now since we know that resistance is rho L by A, okay, A is unchanged, only you are changing the L part. So that means the resistance of each part will be R by 3. Okay, so resistance of each part will be R by 3. Now what is the part? That they are connected into parallel combination and the equivalent resistance is R1. So now these 3 R by 3s are connected in parallel and you have to find the ratio of R1 is to R. Very important, which ratio you are finding. R is to R1 will be a different value, R1 is to R will be a different value. So let's see. So they have done the solution. Let me explain that. First of all, you have to identify that all the resistance has 3 parts R by 3. For that you will get 1 mark, I guess. Yes, for that you will get 0.5 marks. So each of them has R by 3, so for that you will get 0.5 marks. And then once you now they are connected in parallel. So connected in parallel means this all R by 3s are connected in parallel. Now what is the equivalent resistance of 3 resistances connected in parallel? So 3 resistances connected in parallel, the equivalent resistance will be 1 by R by 3 plus 1 by R by 3 plus 1 by R by 3. Right? Or you can say that is equals to the way it is written here, 3 by R plus 3 by R plus 3 by R. Why? Because this is in division, so this 3 will go up. So you can write this as 3 by R plus 3 by R plus 3 by R. Right? So the LCM is R, and 3 plus 3 plus 3, which is equals to 9 by R. Now 9 by R is 1 by R1. So R1 will be equals to, so what is R1? R1 will be equals to R by 9. Don't forget to take the reciprocal. This is very, very important. Many students forget to take the reciprocal. Okay, so R by 9. Now you have to find R1 is to R. So what you can do, you can take this R and you can divide it here. So R1 by R equals to 1 by 9. Right? So the ratio is 1 is to 9. 1 is to 9. This is the answer. Okay, so to identify this, that all of them will have R by 3 resistance, you get 0.5 marks. To write down the equation and finding the value of R1, you get 1 mark. And finally, for finding the exact ratio, you get 0.5 marks again. Okay, so this is how you get the full marks. So identifying and calculating the value of R1, you get 1 mark. For identification of that, once you excuse me, once you cut the wire into 3 equal parts, the resistance of each part is R by 3. For that identification, you get 0.5 marks. So this is very, very important, how you write your answer, how you identify the answer. Now, so now let's look into the second part. As I mentioned that the magnetic field strength is more in the region where the field lines are crowded. This means that field strength is maximum near the poles and it reduces as we go away from the poles. So as I mentioned, the magnetic field is stronger near the poles or the positions along the length of the solenoid. You can mention the length of the solenoid. Okay, just outside the solenoid rings. Just outside the solenoid rings, on the both side of the solenoid, the magnetic field line will be stronger, right? And it reduces as you go away from the pole. So that is very important. You have to mention that it reduces also. And for the direction of the magnetic field also reverse. So to identify that, when you reverse the magnetic current, when you reverse the current, the direction of magnetic field also reverses. To just for this identification you get 1 mark. Now if you are very strong in mathematics, this is a easier question. If you are strong in theory, this is a easier question for you. Right, now which part you want to answer, that is entirely up to you. Both questions are answerable, both questions are super easy. Now next question, section C. So now we will have a lot of questions. This is a 3-marker question. Explain why the refractive index of any material with respect to air is always greater than 1. So you will see that in a while, but I have gave you the hint. If you know, you can mention that in the comment below before I actually answer it. In the figure below, a light ray, and if you are answering it correctly, I will know if you have seen the answer or you have answered it from my previous explanation. Okay, in the figure below, a light ray travels from air into the semicircular plastic block. Give the reason why the ray does not deviate at the semicircular boundary. Okay, so they have said that light ray is traveling from air to some plastic block, and why there is no deviation happening here. This is the first question. Okay, plastic block. Complete the ray diagram of the above scenario when the light ray comes out of the plastic block from the top flat end. So basically they have asked you to complete the ray diagram. So whether it will go in this way or it will bend towards the normal. So you have to identify it, and you have to also mention that why you are doing it. Okay, so that's one line you have to answer that. Okay, light ray is bending away from the normal or light ray is going towards the normal. We will see that and we will come back. Okay, so let's see the first question. Okay, the refractive index of medium with respect to air is given by speed of light in air, that is c, and then speed of light in the medium, that is v. Okay, since speed of light in the medium is always less than that of the speed of light in the air, hence above ratio is always greater than 1. So as I mentioned that refractive index is basically c by v. Right, now c is speed of light in vacuum or speed of light in air. Both cases speed of light, generally c is considered to be speed of light in air as well. Okay, because air is very thinly dense, so most cases speed of light in air is almost equal to the speed of light in vacuum. Right, so now we know that v is always, this is the maximum possible value of speed of light, right? So v will always be less than that of c. Right, so if v is always less than that of c, then this value will always be greater than 1. Right, so we know that whenever we are measuring the refractive index with respect to air, okay, it is a ratio of speed of light in air divided by speed of light in the medium. So that is why refractive index of any medium with respect to air is always less than 1. So this correct explanation, you will get 0.5 plus 0.5, so 1 mark is there. Okay, first you have to write this equation, and then for the explanation you get 0.5. For equation 1 mark, for explanation 1 mark. Okay, now next part, part 2, the light ray undergoing normal incidence at the air plastic interface and normal incidence, there is no deviation. So when we know that if there is a medium and light ray is falling like that, okay, it will pass like that. Right, so for this is called normal deviation. Now as you can see here that the light ray is traveling towards the center of this, suppose there is a sphere, suppose imaginary sphere is there. Okay, then for this the light ray is traveling towards the center. Now what we know, in case of spherical mirrors we have learned, in case of spherical surface also we have learned that this is basically represents the this basically represents the center, that means this must be tangential. So tangential means that this is a normal incidence. Okay, so this is a normal incidence. So normal incidence, light ray does not deviate, only it deviates when the light ray falls obliquely. Now in this case, in the second surface however, okay, the incident is oblique, not normal, so definitely it will bend. And light ray is traveling from a denser medium, which is a plastic, and to a rarer medium, which is air, so definitely it will bend away from the normal. Okay, so credit arrows, refracted ray moving away from the normal. This is very important. The light ray is traveling away from the normal. For that you get 1 mark. And also you have to put the arrows. Without arrows you will miss out 0.5 marks. So diagram you have to be careful. And also if you mention that light ray is traveling away from the normal and you add the arrows, definitely you will get the full marks for this question. Now let's look into the next question. State the law that explains that heating effect of current with respect to the measurable properties in electrical circuit. So what is the law? So heat generation in the circuit is explained by Joule's law of heating. List the factors on which the resistance of a conductor depends. Easy question. So let's see the answer. Joule's law of heating states that the heat dissipated across a resistor is directly proportional to the square of the current flowing through it. Okay, so square of the current flowing through it, and the resistance of the conductor, duration of the flow of current. So basically it says that the heat generated, heat dissipated, so basically you can mention bracket H here, proportional to I square. Here it is proportional to resistance, and here it is proportional to time t. Okay, so this is the first law, first part of the explanation, and the second part is H is equal to I square RT. Okay, so alternative answer. This is also fine. This is also, they have given it as alternative answer, but if you mention all the 3 parts along with this, you get 1.5 completely. First of all, you have to identify this is a Joule's law. Okay, definitely they will give you 0.5 marks only for identifying it is a Joule's law. Okay, secondly, once you mention all the points, for that you will get full marks. Okay, resistance of a conductor depends on the length of the conductor, okay, proportional to L, and then the area of the cross section A, and nature of the material, that is rho. Okay, temperature of the conductor, okay, this is also important. Temperature also, because rho depends on temperature. So this is the main factor. Also you can mention R is equal to rho L by A. Here rho depends on temperature. There is a temperature coefficient of this rho that we have not discussed because that is not part of your syllabus yet. In your class 12th you will learn more about the temperature dependence of the conductivity. Okay, now next question. Ananya responded to the question, why do electrical appliances with metallic bodies are connected to the mains through a 3-pin plug, whereas an electric bulb can be connected with a 2-pin plug? She wrote, 3-pin connections reduce heating of the connecting wires. Okay, is her answer correct or incorrect? Justify what is the function of a fuse in the domestic circuit. So first of all, what is the question? Question was that if you are seeing a refrigerator or an AC or some devices which actually have a metallic part from outside, they tend to have a 3-pin plug, okay, associated. Maybe it's a microwave, maybe it's an OTG, maybe it's a refrigerator or any device, okay, maybe it's a heater, okay, electric geyser kind of a thing. They generally have a 3-pin plug connection, whereas something like electric bulb, they only have a 2-pin plug connection. Okay, only 2 pins are there. So why it is so? So she said that 3-pin plugs actually reduce the heating in the wire. Actually it is not correct. Okay, what is the correct answer? Let's see. Ananya's answer is wrong. Okay, electrical appliances with metallic bodies need an earth wire which provides a low resistance conducting path to the flow of current in case there is an accidental leakage of current through the conductor body of the appliances. Very important. So first you have to answer it if she was wrong or right. Okay, first of all you will get 1 mark only to answer that she was wrong, and you will get one more mark for the explanation that 3-pin plugs are used for metallic bodies because in case some leakage happens, okay, some leakage happens due to some electrical short circuiting, short wiring, or whatever reason it may be, okay, break in the connecting wire, okay, so if there is a leakage happens, that current, extra current is being taken away by the third wire into the ground. Okay, very important. That is why this 3-pin plug is essential for any high capacity circuits, for example refrigerator, OTG, or microwave, or any other heater, geyser, etc. Okay, but in case of bulb there is no chance of leakage because the body is made up of glass mostly, okay, or plastic, so there is no chance of leakage. In case even if there is a leakage happens, the bulb will itself will burn and it will prevent any damage that happens to the user. Also, user generally do not touch the bulb when it is glowing, right? You do not touch the bulb, don't try it at home, but there is a chance that you might open your OTG, you might open your microwave, you might open your refrigerator, and they have a metallic body for heat dissipation, obvious reason, right? And if there is a short circuit happens, then you might get shocked. So that's why, to prevent it from happening, as a safety measure, this third pin is installed. Now, what is electrical fuse? An electrical fuse is a safety device that operates to protect against an overflow of current in an electrical circuit. An important component of an electrical fuse, a metal wire or strip that melts when excess current flows through it. Okay, so as I explained in the past also, electrical fuse is basically a low resistance wire. Okay, it has some power rating. In case the current exceeds that limit, it will burn itself out to prevent any further damage that might happen. In case it will prevent from fire, from getting electrocuted. So all the things that is being done by this small wire called fuse wire. Nowadays, I have mentioned in my previous videos, electrical fuse are not super used in our day-to-day life. We use something called magnetic circuit breakers. Okay, we use the fact that when the current passes through a wire, it produces magnetic field, and in case there is a higher magnetic field, okay, there is a trip switch that can trip in case current is high in the circuit, and reverse magnetic field is produced and it can trip the circuit. So that is called magnetic circuit breakers, which works on the same principle of fuse. Only thing is that in fuse gets burned because of a higher current, or more heat is generated. In case of magnetic circuit breaker, it does not get burned. Only thing it is tripping. Okay, and you can reuse it. In case of fuse, you have to replace the fuse using a new wire or new strip, right? In case of magnetic circuit breaker, it is not needed. You just need to flip it down when the circuit is stabilizes, right? So these are the advantages of MCBs, magnetic circuit breakers. Now let's look into the 5-marker question, the important zone. Now we are into the important zone, and the 5-marker question from this came from the chapter optics. So let's see. The above image shows a thin lens of focal length 5 meter. What is the kind of lens shown in the above figure? So this is what type of lens it is? It's a convex lens, more accurately biconvex lens. But in your class, convex lens is sufficient. Okay, it is a convex lens. Why? Because both sides are bulged outward. So both sides of the lens are bulged outward, so that's why it is a convex lens. If the real inverted image to be formed by this lens at a distance 7 meter from the optical center, then show it with the calculation where should the object be placed. So obviously you have to calculate. So focal length is given 5 meter and image distance is given of 7 meter. Okay, found by this lens at a distance 7 meters. Image distance is given, and they asked you to find where should the object be placed. So you have to calculate the object distance. Very important. Okay, not the other way around. Generally we see object distance is given and we calculate the image distance. In this case, image distance is given and you have to find the object distance. So slightly tweaked, they have tweaked the question. Draw a neatly labeled diagram for the image formation mentioned in 2. Okay, so you have to draw the diagram for this case. Or there is another question. A 10 cm pencil is placed 5 cm in front of a concave mirror. So this is also a full question. As you can see, it has 3 parts. This is also has 3 parts. So this OR is for the entire set of the questions, entire set of the 3 questions. Okay, not for the last part only. So nowadays we see that only one part of the question is given as OR, not the entire question paper. But here they have given OR for the entire question. This is sample paper from 23-24, so we cannot complain. A 10 cm long pencil is placed 5 cm in front of a concave mirror having radius of curvature of 40 cm. Now here in this case they have given you 5 cm. So object distance is given, center of curvature is, radius of curvature is given. Determine the position of the image formed by this mirror. What is the size of the image? Draw a ray diagram to show the formation of image as mentioned in the part 1. So in my opinion, this is slightly longer answer. This is slightly easier answer, because question number 1 is very easy in this case. Question 2 and question 3 are same as the main question. Here question 1 and question 3 are same. Question 3 requires another formula, another equation to solve it. Okay, let's see the answer. So first of all, you can see that convex lens has this is a convex lens, obviously convex lens as I mentioned, and the lens equation is given by for that you get, for all the parts you get 0.5 marks. Okay, so all the parts you get 0.5 marks and 4 marks, total you get 2 marks. Okay, and identifying it you get 1 mark. Okay, so total 1 and 2 you get 3 marks, and drawing the ray diagram you get another 2 marks, total 5 marks. Okay, so now 1 by f is equal to 1 by v minus 1 by u. So there is a mistake here, it will be u, right? We know that 1 by v minus 1 by u is equal to 1 by f. So in this case v is equal to 7 meter, f is equal to 5 meter. Both are positive in case of convex lens, right? Convex lens focal length and object distance is positive. Why? Sorry, image distance is positive. Why image distance is positive? Because it is mentioned a real and inverted image. So real image means obviously it is happening on the other side of the lens, or that is on the right hand side of the lens. So definitely it will be a real image. So real image means this distance will definitely be positive. So be careful, right? Once you put the values, you get the value of u to be minus 17.5 meter. Very important. The final value should be negative. Okay, why? Because u should be negative. Now here they have drawn a ray, this is not a ray diagram. Okay, even though they have tried to draw it, they have taken it from somewhere. This type of ray diagram is not necessarily be required. What is important is that you have to draw the principal axis, you have to draw the lens correctly. Okay, and then remember that you have found the distance to be 17.5 meter. Okay, the focal length is 5 meters, so definitely it will be more than 2f distance. So this is suppose f, you have taken this to be f, this is 2f. Okay, so it will be somewhere here, it will be outside 2f region. That is very important. You have to identify. Okay, so here they have also in the answer also they have mentioned that object placed beyond 2f, okay, on the left. So very careful, object must be placed beyond 2f on the left. Okay, because this is negative. Now you have to draw the diagram. Now what are the diagrams that you have to be careful? First, 2 rays are compulsorily you have to draw. What are the 2 rays? The easiest ray is this ray parallel to the principal axis, and after passing through the lens it will pass through the focals, right? And secondly, you have to make it pass through the optical center of the lens. So take a scale, join these 2 points and extend it. Okay, and you will find it will be forming between f and 2f. Very important. It will be forming between f and 2f, and it will be diminished. So these are the main things that you have to be careful about. Okay, so 2 rays, arrows. Okay, I missed 1 arrow. 2 rays, arrows, and object must be placed beyond 2f on the left, and image must be formed between f and 2f. They have skipped it, but that is also very important. Okay, so these are the 3 parts that you have to be careful and to get the 2 marks. Okay, not only drawing the diagram, diagram has to be correct, right? So how to measure the diagram is correct. 2 rays has to be drawn, the object must be placed beyond 2f, and the image must be forming between f and 2f, and you have to show the arrows on the ray diagram. Without arrows you will not get marks, they will deduct marks. Okay, when I was a student, if you are not giving arrows, they will give you 0 marks. Right now maybe they will give you some marks, but they will definitely deduct marks. Now let's look into the OR question. In case of OR, U is given, and by default U is always negative, as I should say that U is always negative, and focal length is basically for a concave mirror or concave lens, focal length is also negative. So in this case focal length is r by 2. So U is given, R is given 40. They have forgot to mention that has to be mentioned as well. This is the given data. So R is 40, so F will be R by 2, that is minus 20 centimeter. Now you use the lens equation, mirror equation. 1 by F is equal to 1 by V plus 1 by U. Calculate V, which will come out to be 6.67 centimeter. Okay, 20 by 3 means 6.6 into 2 by 3, so it will be 6 into 2 by 3, that is 2 by 3 is basically 0.67, right? 1 by 3 is 0.33, right? You have to remember these values. Okay, 2 by 3 is approximately 0.67, 0.66666, but approximated to be 0.67. So this is the V. Now you can see that V is coming out to be positive automatically. Okay, if you have put these values, V is coming out to be positive automatically, right? So that means the image is a virtual image. Image is forming behind the mirror. Very important. That's why I said this part is tricky. First part was first 3 questions was easy. These 3 questions are slightly tricky, so you have to be careful. Okay, now magnification is given by H2 by H1 or minus V by U. Very important. For a convex mirror you have to, or for mirror it will be minus V by U. For lens it is only V by U. Okay. Now put the values. It will be 4 by 3, so definitely it's a magnified image. Okay, and the value is coming out to be positive. Okay, here they have cancelled the negative sign directly, so you have to be careful. Negative sign was there, and because U is negative, these 2 negative sign will cancel. Okay, these 2 negative sign will cancel, this original negative sign and the negative sign from the U. Okay, so that's why this is positive. So basically positive means it's an erect image. Okay, if it is a negative value, that means it's an inverted image. Now erect image, V positive, then definitely it is behind the mirror and it's a virtual image. And in case of concave mirror, we know that it forms a real image, virtual image when the distance is less than the focal length. So once you are drawing this ray diagram, okay, suppose this is your F, okay, this is your 2F. Now remember that in case of this is your radius of curvature, not 2F. In case of concave mirror or convex mirror, whenever you are drawing the ray diagram, thus radius of curvature comes automatically. The radius of curvature comes automatically. Why? Because this is the point from where you have put your compass to draw the mirror. Okay, so this is the point where you have put your compass to draw the mirror. So if you have drawn it properly, then suppose I always say take an even value, for example 10 centimeter, 8 centimeter, 6 centimeter, based on the area that available to you. Suppose you have taken 10 centimeter radius, you are drawing it in a horizontal format. Okay, you have flipped up your answering sheet to draw this ray diagram. So what will be the case? In that case 10 centimeter means this will be automatically 5 centimeter. So these things will come automatically when drawing the ray diagram. Now in this case the image object distance is less than that of the focal length, so object will be placed here. Okay, and you have to be careful. The first ray that you can draw is the ray through which it is parallel and it will be passing through the focus, and second ray will be joining the radius of curvature and this point, and you have to extend it. it will not go anywhere, it will just go in this direction, it will come back in this direction, right? So you just need to make them backwards, they will meet somewhere and the image will be formed. Okay, and if possible, what you have to do, you have to make this arrow with a dotted line. So dotted line represents a virtual image, right? A dotted line represents a virtual image. You don't need to use this candle, etc., this complicated diagram that is given in the standard sample answer paper, but if you draw it using arrows, you get full equal marks. No need to show candles, right? Because also you have seen your CBSE books or NCERT books, there the everyday diagram is drawn using arrows. Okay, so two rays, arrows, objects placed between optical center and the focus. So here it is important that object is placed between the optical center and the focus. Okay, and the image is virtual and upright or erect. So these are the important things that you have to remember while drawing this ray diagram. Now last question, that is a 4-marker case-based question. Vinita and Ahmed demonstrated a circuit that operates the 2 headlights and 2 side lights of a car in their school exhibition. Based on their demonstrated circuit, answer the following. So this is the demonstrated circuit. Okay, so I guess this is the headlight, this is the side light maybe. First of all, state what happens when the switch A is connected to position 2, position 3. So you can see there are 3 positions, position 1, position 2, position 3. So when the supply is connected to position 2, okay, headlights, these 2 headlights are turned on, so the 12 ohm headlights are turned on, whereas when the switch is connected to position B, only 4 ohm lights are turned on, right? So these are the 2 positions. First of all, you have to explain that when the circuit is connected to 2, only current is passing through the 12 ohm lamps, so only these 2 lamps are functioning, these 2 lamps are still open, so no current is passing through it. When you connect this switch to circuit 3, then automatically the circuit 2 is broken, so only current is passing through the 2 4 ohm lamps, so these 2 lamps are working. So this is very, very clear. Okay, so these 2 lamps will work when it is connected to point number 2. This will function when it is connected to point number 3. Find the potential difference across each lamp when lit. Calculate the current in each 12 ohm lamp when lit, in each 4 ohm lamp when lit. So first of all, find the potential difference across each lamp. So when the lamps are lit, okay, you can see that. So question number 2 is actually easy. Maybe it appears to be difficult, actually it is easy. Suppose first we have connected this switch to switch number 2, point number 2. So in this case what happens is that this end, you can ignore this part. So for that you can ignore this part. So basically you can say, okay, what is the circuit looks like. There is a battery, I am drawing the simple battery. Okay, we have 2 lamps, 12 ohm. One is this. I am not drawing the lamp diagram, I am just drawing the circuit diagram. Okay, so this is 12 ohm, this is 12 ohm, right? So as you can see that here both the lamps are connected parallel to the supplying battery. So that's why both lamps will have the same potential as the battery. So in this case both lamps will have same potential of the battery. So definitely both of them will have 12 volt. Similarly, this is when the connected across 2, circuit number 2. When it is connected across circuit number 3, definitely same way, the circuit is again connected in parallel, only the resistances are changed. So it is 4 ohm, it is 4 ohm, so it is again connected in parallel, and in this case also they will have the same potential, that is 12 volt. Okay, because the connections are parallel, in each case when it is connected in 2 or in 3, the voltage will be 12 volt across all the lamps when lit. So when 12 ohms are lit, again 12 volt. When 4 ohms are lit, again 12 volt. Okay, now there is a OR question for the last part. that is, show with calculations which type of lamp 4 ohm or 12 ohm has the higher power. So you have to calculate the power and you have to show, okay, this has a higher power. So from there you can say this is the main headlamp, this is the side lamp. Let's see the answer. So in first case only 12 ohm lamps are on, okay. In the second case only 4 ohm lamps are on, okay. So this is the first case. You have to mention that when it is happening, okay, when the switch A is connected to position A and position 3, okay. So there is a slight mistake here. This will be A, this will be part A, this will be part B, okay. So for part A only 12 ohm lamps are on lit, and in this case only 4 ohm lamps are on, only 4 ohm lamps are on. Very, very important to mention. 12 volts for both set of lamps and all of them are in parallel. Very, 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 very important. All of them are in parallel. This, without this line you will not get any marks. Okay. Now question number 3. 12 ohm lamps are now, when the wire is connected to position 2, voltage across both 12 ohm lamps are 12 volt. So from the Ohm's law, current across both the lamps is 1 ampere. So let's see. So here, as I mentioned, that both lamps are connected in parallel, right? So voltage across this is 12 volt, voltage across this is 12 volt, voltage across this is also 12 volt. Okay, so what is the current? V is equal to IR, or I is equal to V by R. Now every lamp in this case, they all have same voltage. Only thing that we have to do, we have to just divide it by corresponding resistance. So it will be 1 ampere for this. Both of them will have 1 ampere through them, 1 ampere through this, 1 ampere through this, right? Now what is the current through this? In this case it will be 12 by 4, so 3 ampere through this and 3 ampere through this. Okay, so now, so both of them will have 3 ampere, both 4 ohm lamps will have 3 ampere through them. Okay, so all the lamps are in parallel and hence the same V for all the lamps. Okay, so for 4 ohm lamps, power will be either you can use resistance by voltage square V square by R formula, or V by VI formula. Both are okay because you have calculated I. Sorry. So in this case, second part, the current is unknown because you have not solved for the current. This is a OR question, right? So the formula that you have to use, power equals to V square by R. Okay, all of them are connected in parallel, so we already know that all the resistance across all the lamp is 12 volt. That is already known. So for each power you have to calculate the power by dividing by resistance. So as you can see that 4 ohm lamps actually have 36 watt power, whereas 12 ohm lamps have 12 watt of power. Okay, so this is consuming more power, so hence 4 ohm lamps will have higher power. So basically 4 ohm lamps are actually the main lamps or head lamps because it has more power compared to the 12 ohm lamps. 12 ohm lamps are consuming less power, so basically they are acting as a side lamp, right? So I hope you enjoyed this little session, and I will be back with sample paper 3 next week. Till then, bye.